So I watched the video last time, but I was kind of trying to do homework at the same time. So what was the project we decided on? Was it buying packs of M&Ms?
Yeah.
Okay.
So what we're going to do is we're going to each buy 10 of the
The
fun
regular.
size.
Oh, the fun size.
Fun
Okay.
size mini. So like, if you're for Halloween, you could buy one of those bags and it's got a bunch in there.
Mm-hmm.
So get 10 of those fun size ones, and
Okay.
you're gonna record the number of each color in those fun sizes.
Okay. Gotcha.
That's what we're gathering, and then what we're going to do is we're going to decide. We figured our hypothesis is that the proportion of colors is equal, which we actually think it's not, but that's our hypothesis. No, the null hypothesis is that the proportion of each colors is equal in
Uh-huh.
each pack.
Okay. Gotcha.
And then we'll do an, a ANOVA. We'll do an ANOVA, and then we'll have 50 samples, and that way we can tell. So we'll have all of our samples along the side and the colors across the top, and then we can decide, if there's one that is got a different proportion or a different proportion than the others.
Okay. Gotcha. Makes sense.
So we assigned you a section. I can't remember actually which section we assigned you.
I can go back and watch it again.
Now we'll have the list. Austin is submitting first. He's submitting he's setting up the.
The study, designing the study.
Yeah, thanks.
Okay. Cool. Yeah, I'm sorry I've been missing a lot of the meetings. It's just everything. My teachers, they just put everything on the same days.
Oh, that stinks. That's no good.
Yeah, I got a bio. I didn't even do the prepare, I'll be honest, for this because I got a bio test to do at 9 in the morning. But I got college algebra homework due at midnight tonight. So,
Oh boy.
yeah.
Well, good luck with all that. That's not cool.
Yeah, it's.
How many classes are you taking right now?
Let's see, 4 of them:
Yeah.
molecular biology, bio 181, college algebra, and this one.
Yeah, those are all heavy classes.
Yeah, I didn't think they would be, but they're turning out to be.
Yeah. I'm going to set another invite out here. I got a notice from Jared. Jared Ferguson. He's not going to be able to make it tonight.
Okay.
I wonder where the other guys are though. Hey, buddy. How was scout camp?
I made this. There's supposed to be a buffalo and a W there.
I see the buffalo on the top, and I can see a little bit of W there.
And
Nice work.
this may look just like a ball with a bunch of beads in it.
Mm-hmm.
Wait. Tic-tac-toe board.
Whoa, that's pretty cool.
I
Uh-oh.
need all of
So you can play the game?
need all
Nice work.
That's a slider.
Yeah, for your neckerchief.
Yeah, and I can wear it to scouts as well.
I like it. Did you have fun today? Good. You did good work.
And I did really good on BB guns.
Yeah, you did BB guns again today?
I did really good, but I was aiming at the wrong target. So another kid got it.
Oh, no. But you did hit a target, right?
Yeah, I hit the target like 5 times.
Well, now you know that you got to make sure you're aiming at the right target, right?
Yeah, I was really good at BB guns, but I didn't get the wrong target.
So did what we talk about help? Using the sights?
I used the sights.
Good.
But I didn't use the rear sight because I couldn't find it.
So how did you use the sights if you didn't use the rear one?
I used the one in front.
Oh, okay. All right, I got to get back to my meeting, buddy. All right, see you, dude. Sorry about that, Zach.
Oh, no worries.
Well, I wonder if, let's see, do we have any emails from the guys?
Yeah, I didn't see any.
Well, maybe we'll get started without them.
Yeah, that's fine.
Okay. All right, so part 1, let me go back up to the top. So when given a sample, what is the formula for the point estimate P hat for a population proportion? Explain what each variable stands for in your formula. So P hat is X over N, and X is the number that's correct, or the number that you choose.
Right.
And N is the total number in that group. So the total number of whatever it is you're searching for, that's the total number.
Okay, gotcha. All right.
Is that right? Yeah.
So the number of successes is X, and then N is the number of trials.
Okay.
Number 2 was the formula for the one proportion confidence interval for one proportion. Let's see, what was that? That was that's the wrong one. So P with the top hat minus the z-score times square root of P minus 1, P, all that, divided by N. Is that what it is?
Yeah.
Minus 2. Okay.
Yeah, so it's the same kind of confidence interval we've done before, only that you were using P's and they use the.
Okay, gotcha.
Yeah, so it's the plus or minus.
Yeah, all right.
What are the conditions required to build a one proportion confidence above? So let's see. It's N times P hat. It has to be greater than 10. So it has to meet one condition there. And then it also has to be N times 1 minus P hat. It's got to be, also has to be greater than 10. Greater than or equal to 10.
Gotcha. All right. 4, if no prior estimate for the population proportion P is available, what is the sample size formula to get the needed sample based on desired margin of error? Explain what each value stands for in your formula. Let's see. Is that the... No. Margin of error.
Excuse me.
I don't have that one. Do you got it?
Yeah.
Wait, no
So
prior.
so if we don't have a prior, did you find it?
I think so. So it's n equals z star. What does that mean? The z.
The Z star is
What is that? It's not the z score, right?
it's uh, it's not the Z score. Shoot, I remembered it from the video, but now I just noticed I didn't write it down on my notes.
Oh, no worries. Let's see. Let's see.
I think I have the video still open.
Um, it says you can use the probability output to compute z star.
I mean, I think it's the Z score, but it has the Z score of.
Oh, so it involves the confidence interval. So z star would be like 1.96, which would be for the 95% confidence. Okay. Huh. Well, anyway, so it would be the the z
So
star.
so I guess it is the Z score, but I thought there was something. Yeah. So sample size calculations I'm looking at right now.
Oh, okay.
Oh, so Z star is it's the it's the given value or the known value of the confidence interval. So if it's 95%, then it's
1.69.
1.96, and 99 is 2.58.
Gotcha.
Okay.
Okay. So that equation would be the z star divided by 2m.
Yeah.
All that squared, right? That's what n would equal.
Right. Yeah.
Okay.
And M is the margin of error, 2 times the margin of error, right?
Sounds good to me.
Yeah, the margin of error is M.
Okay.
Okay, so let's see. What's the next one?
Yeah, that's right. Okay, it says right there. Yeah, margin of error.
What is the test statistic for a hypothesis regarding the population proportion? Okay, so that's the Z equals P hat minus P divided by that formula for the confidence interval, which is the square root of P times 1 minus P over N.
Okay. Number 6. What are the conditions that need to be satisfied so the sample size is large enough that the central limit theorem suggests the sample proportion is approximately normal? So NP needs to be greater than or equal to 10, and also N 1 minus P needs to be also greater than or equal to 10. It's kind of the
Yeah.
same as the last one, isn't it?
It's the
I
same
know,
as number 3, yeah.
but it's got a P involved. Gotcha.
Yeah. All right. So part 2, let's see. Part 2, number 1 is a confidence interval. In an October 2008 poll, 684 out of 1,006 randomly selected college students reported that they had been involved in an automobile accident in the last 5 years. Find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So the proportion is just the number of people in an accident. That's 684 divided by 1,006. I'm going to stick it in the spreadsheet they gave us. 684, 16. And so our P hat value is 0.680.
Okay.
Let's see, they have it rounded out a few more decimals. 6.7 or 0.6799. Okay, and then checking the requirements. So I've just got it keyed into the categorical analysis.
Okay.
Do you have that spreadsheet?
I don't. Let's see.
Let's see. Let me see if I can help you find it, because that'll make things a lot easier.
Yeah.
It's okay. So if you've got the chapter open on the wiki,
Mm-hmm.
go down to section 2.3
All right.
and open up categorical analysis .xls.
Okay. Cool.
And then I think it takes you to a different page, and then you click on the categorical data analysis.
Okay, gotcha. All right, got it.
Well, I think I'm going to send out one more invitation to those guys.
Okay.
Okay. All right. So were you able to open that up?
Yeah, I got it.
Okay. So that makes the calculations a lot easier.
Yeah.
Okay. So then you'll notice down there where it says descriptive statistics.
Mm-hmm.
It shows. Wait. No, I'm sorry. Above that, it says confidence interval requirements.
Yeah.
Both of those need to be greater than 10. So the first one is the n times p hat, which is I think the first one is.
And
Oh wait, no.
it would be 684. No, is the 1006, right?
Yeah, it's the. So that's the 684. Wait, what?
Because isn't in the total number?
Yeah. Oh, but then but you times it by p hat, which is the 0.6799,
Okay, gotcha.
which is how you get the 684.
Oh, okay.
And then the other one is the n times p hat, or I'm sorry, n times 1 minus p hat. And that gives you 322. So both of those are way above 10.
Okay, yeah, gotcha.
Okay, and then the margin of error. So we can use the formula, which would be the what's a 95% confidence interval, which is the 1.96 times the p hat minus 1 minus p over n. Or you can look at the confidence interval. I'm sorry, the margin of error.
So Z, let's see. Z star square root P minus 1 minus P.
Oh, I thought it had the.
Which one are you guys on?
We're on section 2, item number D.
Oh, okay.
We're figuring out the margin of error for the 95th percentile. And I was using the categorical analysis. By the way, how you doing tonight?
Oh, I'm like, sorry, I'm not feeling well.
Uh-oh, that ain't good.
Yeah. I don't know why.
You heard from Jared?
No, I haven't. I know his car's there. He wasn't at clinicals today.
Maybe he's not feeling well too.
I don't know what. Yeah, and it just went to his voicemail.
Okay. No. Okay, so we're doing the margin of error for. Do you want to back up and do A and B on that confidence interval one?
No, I should be fine.
You're welcome to get situated for a second if you want.
Confidence interval being numbers. We round up, right?
Yeah.
Oh wait, I'm still getting not that number.
Which one? Which one are you working on?
Oh, a 95 confidence interval.
So you're on
Oh
question
wait, that's
number.
the margin of error.
You're on part 2, question 1, section A.
Yeah. Well, for D, for the confidence interval, I got 0.6511 and 0.709.
Oh, yeah. Let's see. Oh, sorry, I was still on C. So Zach, did you see how we got to 0.288 on the margin of error?
Yeah, I didn't get the. I didn't. I mean, I know the equation. I didn't actually do it myself though.
Okay, no problem. It's not part of the spreadsheet they gave you, so you have to calculate it yourself.
I wish it was.
Yeah. Yeah, I think I might add the formula at the bottom there. Okay, so anyway, so Austin, what did you get instead of 06 or 0.6511
For
and
the confidence,
708? Yeah.
confidence interval was 0.651.
Oh, yeah, that's one that you did get that one.
Yeah, that's what I got.
Okay. All right.
And that was just from putting the numbers into the thing.
Into the thing, yeah. Did you see that, Zach? That one, okay.
The
So if you have that first tab open, one sample Z test for a proportion, all you have to do is key in the X value, the N value, and the confidence level percent.
Oh, okay, gotcha.
And then down on the bottom it says one proportion Z test, and you can see the confidence intervals there.
Oh, okay, I gotcha.
All right. Okay, so E is how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015. Okay, so that one you have to put into the other formula.
Let's see.
So we don't have a prior estimate, so we have to use that Z over 2m squared.
Z over 2m.
Let's see. that doesn't look right.
Hmm.
Oh, I've got the wrong margin of error in here. What am I doing wrong?
Where's the 1.96 come from?
1.96 is the
95% confidence, right?
yeah, that's the Z for the 95% confidence interval. That's the one we use for.
Oh, that's the number.
all-
Right? Yeah.
Yeah, you got it. Yeah.
It's like if you do 95 or the 68, 95, 99
You got it.
correlation. Okay.
Okay. Did you guys get that one? So the answer is 4268.4, and on that one we always round up because you can't have a half a person. So the answer is 4269.
$42 points. Wait, 4269 you said?
Mm-hmm. Does that make sense to everybody? How we got that?
I think so.
So we're using that formula if we don't have a prior estimate. So that's n equals the z-score or the z value of that 95%
Over 2.
over 2 times the margin of error. And they gave us the margin of error, so you
Okay.
just have to run the formula through. Okay. You all right with that, Austin?
Yeah, my margin of error number is just not coming out.
So what's the margin of error then in this?
It's 0.015. It gives you that. It gives you that in the question.
Yeah. Okay. Sorry.
Yeah, that threw me off at first because I was using the old margin of error from our
Yeah.
the previous question.
Oh, okay, yeah, that makes it much more sense now. I was like, that's not the numbers I'm getting.
Yeah, me too. Okay, you get the 4269 now?
Yeah.
Okay. Should we move on to question 2?
Yeah.
Okay. Zach, do you want to read that one?
Sure. Now you are interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use the level of significance of sigma equals 0.05. So number A, state the null and alternative hypothesis. Null hypothesis says you are interested in testing a claim that over 60% of all students have been in the car. That, I guess the null would be that 60% of all students have been in a car accident in the last 5 years. And the alternative would be that they haven't, or either less than or greater than, right?
Yeah, so they're saying greater than, so we want to do the greater than.
Okay.
Doesn't it say more than?
Over, yeah, okay.
Yeah, over. Yeah.
Over 60%.
Mm-hmm.
Okay, so then B, you just compute the z-score, and if you put it in the spreadsheet, it spits the z-score out of 5.1743.
0.0.
Yeah, that's what I'm getting. 5.1743.
Yeah.
5.14,
on,
I got the 4.
on the answer, they have 5.173.
Oh,
They're
yeah,
wrong.
174, yeah.
Yeah, so did I.
Huh.
Another one of those. All right, so then the p-value based on the test statistic. Well, they want you to sketch it. So I have a p-value of 0. What do you guys have?
Same.
Okay.
Let's see. P-value. Yeah.
Oh, well, yeah, it would be. Look how high the z-score is.
0.1. Yeah, okay.
Yeah, so your 5 standard deviations out there. So, based on that, the p-value is way lower than 0.05.
Yeah.
So we reject the null hypothesis.
Mm-hmm.
And based on that, we have sufficient evidence to conclude that the true proportion of students
Is greater than 60% that have had a accident in the last 5 years.
Yeah. Wow.
Let's hope that's not
Seems
true.
longer.
What's that?
I said, hope that's not true.
Yeah, me too. What did you say, Austin?
I just think it just sounds weird. The whole yeah, how it comes out.
Oh, yeah. Getting some feedback too.
I'm gonna put on some old polls.
Okay. Is that better? No, we're
Yeah.
still getting it. Okay. Oh, I'm still getting some feedback here. I wonder if it's on mine.
I have headphones in, so I don't have any sound reverberating through my.
Yeah. Zach, do you have any headphones?
I do. I can go get them. I'll be right back.
All right. Sorry.
Oh, no worries.
Hey, Austin. So I talked to our professor, and she said that that I could submit your portion just on my account. So when you're finished up with it, if you want to just email it to me, then I can put it in for us on our side.
Okay.
And she knows you're in our group, and it's cool. So
Okay.
just so she has something
Awesome.
she can look at too.
Mm-hmm. Awesome.
Groovy.
Okay, I got headphones. Is that better?
Yeah.
Okay, cool.
Thanks.
Yep.
Can you hear us all right?
Yeah.
All right, good. Okay, should we jump into the quiz?
Yes, sir.
All right, here goes nothing.
Symbol for the true population proportion is it p hat?
The true population proportion?
I was thinking the true population
Just
proportion
P?
is just P.
Oh, okay. Oh yeah, that's just you're right. Sample. Okay. Yeah.
That's what I was thinking. Just P.
Okay.
And then first one we have to multiply n times p hat and then n times p minus, or 1 minus p hat.
Yeah. We could probably, I wonder if we can put it in the
Comes
thing.
out to be 10 and 90.
$10 and $90.
Yeah,
Okay.
I think that's what the numbers off the top of my head are sounding like. Because 100 times 0.1 is 10%, 10% of it. And then 1 minus 0.1 is 0.9, 0.9 times 100.
Okay.
Mm-hmm.
So the confidence interval is satisfied. And the hypothesis test. Let's see.
So it just has to be greater than 10, greater than equal to.
How do they calculate it here on the spreadsheet? So they have the number times the null hypothesis.
So does x equal p or p hat?
X is the number of I don't know.
Let me go back to my equations. So I'm guessing x is p hat, because that's why everything in all the numbers are based off p hat. Oh no, p
Okay.
hat's found down there though, isn't it? Which is that way. I don't
Okay.
know, I'm getting confused.
No problem. Okay, so I'm looking at the wiki, and about the hypothesis test, they want n times p to be greater than 10. Right?
I think we have enough, don't we?
It's on the homework it says, on my answer key it says n times p hat has to be greater than 10. And then n times 1 minus p hat.
Is that for the confidence interval or the hypothesis test?
That is for confidence interval.
Oh, okay. I was looking at the.
So, because the question is what conditions required to build one proportion confidence interval above?
So are you on 4 or 5?
For the quiz?
On the quiz? Yeah. Are you on 4?
Yeah, so forwards that 5, well, 5 is just P.
Yeah, 5 is just P. Okay.
So 5's true then?
Well, let's see. One part of it is 25, right? So N times P is 25,
That'd probably be 75.
and the other part is 75. Yeah. So it meets both of them, right?
I think so.
Yeah.
Yeah. Okay. All right. Somebody want to read 6?
Yeah, I can do that.
Cool.
Study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. Find p hat, the point estimate of the proportion of first-degree murder defendants who are found guilty in this state. Around 3 decimals. All right.
So we have 45 and 60. So p hat is 0.75.
Yeah.
So 45 you put in as X and 60 as N.
That's what I did. Yeah.
So it's 0.750.
Yeah. So you got?
Yeah. Number 7, create a 95% confidence interval for the true proportion of first-degree murder trials in this state where the verdict is guilty.
Confidence interval of
95. So yeah, 1.96, right?
I got 0.640. I got the second answer.
Okay. I didn't. What am I doing wrong here?
0.640 and 0.860.
Yeah. Okay, so I've got 45 in the X. N is 60. My confidence level is 0.95.
And that should be what your confidence interval is based off of.
Yeah.
Yeah, I got 0.654 and then
Oh.
0.826.
Sorry. I was looking at the standard deviation. Sorry.
You got 0.654 though?
I got 0.640 and 0.859, which is number 2 for me. Isn't that what you said you had?
That's what I got.
And what did you have, Zach?
Zach got the first answer.
Yeah.
Is he?
Let's see.
Okay, so what's your X input
45.
and your N input
60.
and the confidence level?
0.95. That's weird. Let's see.
And do you have greater than, or I guess that shouldn't even affect it.
Shouldn't matter, and your null hypothesis
Yeah.
shouldn't matter either.
What
I do
is
have
your
greater
standard
than.
deviation?
Standard deviation.
Of confidence interval.
0.0559.
That's weird. That's
That's
why I
what
have
mine
to-
is too.
Okay, and down here on your confidence interval, you have point what?
0.654, and then the other one's 0.826. So it's not even. I just got the first answer for the first one, but that was
What's your p hat?
p hat 0.75. Huh. That's weird. Oh well, let's go with yours too. You twos. I wonder why.
Why is yours different though? I don't understand what.
Maybe it's just a glitch.
Yeah, I'd like to know what the glitch is though.
I got it now. 0.686. I had to put it in a different format. The one I had with the Excel online doesn't do it right, so I just put it in the Google Sheets, and now it's got it. We're good to go.
Oh, interesting. Okay. All right. So we're doing number 2.
It's kind of weird.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
I'm thinking it shrinks.
I agree. It's going to be the other way if you
Decrease it?
If you, yeah.
Or if you increase the P?
Right. Okay, so decrease. Number 9, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest n can be, and both requirements still be met?
20. So I'm thinking.
Yeah, because then it would be 10 and
1 minus
1
0.5
minus.
times 20. Yeah, 20.
Okay.
Because 1 minus 0.5 is 0.5, and times 20 is 10.
Right. Okay. And
Same question, but with 1/10, which is 0.1, which is what we had before. So the smallest for that would be
would that
100.
be 100?
Yeah. That's what
Does
I'm
it
thinking.
satisfy the other part of it? 100 minus
90.
1/10 would be 90. Yeah.
So if you were to do anything smaller than that, like 80, it would come out to be 0.8 times, it would be 0.8 or 8. Yeah, it has to be at least 100.
Okay.
60% micro water. Macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that the quality of this area has decreased. So we're going to change that to less than real quick. Conduct a hypothesis using significance of 0.05. This hypothesis. And okay, here's our data. N equals 80 and X equals 38.
What's our confidence level? Doesn't say. So do you have the hypothesis test requirements you have are 40 and 40?
No. The hypothesis test, I have 48 and 32.
Yeah, that's what I got. 30, 40, and 32.
That's what. Yeah.
Okay, so what am I doing wrong here? Oh. All right, 48 and 32.
8.
Okay, so the conditions of the hypothesis test are satisfied. That's true.
What is P hat?
I have 0.4750.
Same.
Zach, is that what you got?
yeah, there we go.
Okay.
Test statistic.
All right, and this test statistic, the z-score.
Z, I got negative 2.282.
That's
Yeah,
what I have
that's
as
what I
well.
got.
Okay. And the p-value is 0.011.
Yeah.
For the p-value, I got
Zach, we lost you.
yeah, we're good.
Okay. So then, are we going to accept or reject or fail to reject? Looks like we're going to reject.
Yeah, it's less. Yeah.
Austin, you good with that? Reject it?
Yeah, reject null hypothesis, and then I put the first one for 16.
Okay. So yeah, it has to be
Yeah.
sufficient evidence. Yeah. All right. Ready to submit?
Yep, I got 100.
Yep.
Cool.
Yeah, there we go. Nice.
I like that.
Yay.
Boom. Cool. All right. Thanks, guys.
Yeah.
Yeah, thank you.
Okay. So you'll just send me your proposal or your submission on
Yeah.
when you get it.
And I should have that done tomorrow morning.
All right. No worries. Thanks, Austin.
Yeah, no problem.
Yep. Hey, get feeling better, dude.
Yeah, I don't know why I'm feeling all like crap after clinical, but I am. But good luck on everything.
Yeah, you too. Thanks. Bye.
Bye.